The term cloud washing is putting a bunch of different pieces together from disparate technologies and calling it cloud. You have to build it in order to consume it. You're basically starting from the bottom, so you think your compute, your storage, and your networking. You have to put a virtualization layer on top of it, and then you have to figure out how to put the scalability functions on top of that, and then you have to figure out how to make access and things such as that on top of that one. You're kind of pulling all of those different components together in order to build this into a pyramid that reaches the top so that you can consume it. But it ends up being a very cumbersome experience from the start, because you're starting from the bottom and trying to go up. You're kind of bolting pieces onto the system, and there are limitations to it. It's a software stack that's running on that commodity hardware, and so there's no real interoperability between the two. There's a disconnect that's happening. The software guys don't really care. They just know that they have to do things in a certain way to run on that particular hardware that hopefully will do the job. It becomes very difficult and cumbersome to grow because there are limitations to whether it's on the hardware side or the software side in order to reach the same spot. Security is interesting because from a security standpoint, if you don't start with a foundation of a secure approach, you end up trying to bolt on after the fact the security aspects or the secure aspects of the solution that you're trying to work with. And what ends up happening is very similar to building a house. If you have a foundation that's cracked and you have to refix the foundation or repair the foundation after you've already built the house, the stability of the house is greatly impacted. That's ultimately where it becomes very difficult utilizing the traditional infrastructure. They didn't really start with a secure idea in mind. They bolted on the secure aspects after the fact, or they even leave it up to you, the customer, which may or may not always work if you don't have the expertise or the understanding of what needs to be done for that particular instance. Multi-tenancy within the traditional stack of things is extremely difficult. Having the valid and functional separation of access requires you to be able to kind of carve pieces off of the computing side or memory. You have to be able to do really strong tuning of the system, and it's very difficult. There are very few people that really have the deep hardware architectural knowledge to be able to interact with the software in an appropriate way to separate those pieces in order to really do multi-tenancy. It's very difficult to do from a traditional standpoint. Chargeback is one where businesses have been trying to do it for decades. The misstep is not having the complete control over the hardware to be able to surface that information. The software is built to do something else, and when you try to figure out how to really truly interact with the hardware that's not yours, it's never going to surface the information that you're looking for. And so that true response or true chargeback capability is just not there. When you have multiple different systems that all have different requirements, each one of them has a different set of rules that you need to follow in order to just simply do the upgrade. There's dependencies between each of them, which means you have to manage all of these pieces, determine the versions that are all going to be compatible with each other, figure out which ones you need to upgrade or do the installation for first. And if you make a mistake because you haven't done your research enough, you could completely tank the entire system.